Sorry, didn't see you there. But now that I have your attention, let's talk about our 1.1 notes, the sky from Earth. So they look like this. Follow me along on 19, 20, and 21 and my handy-dandy globe. So 19 and 20 are together as an answer, but let's talk about the overall concept. So the Earth is a sphere, so it's hard to pinpoint, well, you know, it moves exactly in this direction, because it is a sphere. But taking from our perspective on North America, all right, as we here in Pittsburgh, right here on this portion, we experience light moving from this direction to this direction, which would be east to west. So west and east to west. Therefore, we are moving as a planet this way, west to east. That's because the light travels across our surface like this. Now, when we go and talk about further detail on rotation and revolution, we'll talk more about that later on. So, for number 19, it says, in which direction do stars appear to move? That would be east to west, because they're moving up. They would appear to move this way, whereas we are moving this way, so west to east. And this relates to you traveling in a car, because as you travel in a car, this is your car right now, your car is the Earth. As you travel in a car, and say you see this marker floating in space, as we travel past that marker, we are moving past it. It appears that it's moving backwards. Next time that you're in a car, notice that phenomenon whenever you pass a light pole or a house or something like that. You can see it. It appears to be moving behind you as you move. And now, so you can draw that in your head, or you can think about that. So number 25, let's pay attention to me as I draw this on my whiteboard. All right, so you can see my whiteboard on here. So draw along with me. So in the very center of our whiteboard, we are going to draw our sun. And obviously the sun needs sunglasses because it is too bright and needs to protect itself from all of those harmful rays. All right, so you need to have sunglasses on your sun. Scientifically speaking, it's just the way it has to be. I'm sorry, I don't make the rules, I just follow them. So let's put the elliptical orbits of our our 6 planets, our first 6 planets. So that would be, and you can say them together, you can say Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Now, nice big loops, not perfect circles. They are ellipses, which, again, we'll talk a little bit more in the next section. Again, this is an overview, but this is just for an FYI little thing. So let's place our 2 innermost planets, Mercury and Venus. That doesn't matter right now because that's not really going to be what we're talking about here. So we just draw Mercury and Venus. All right, so you have your Mercury and Venus wherever they are. Then our 3rd planet from the sun would be Earth. Very good. So Earth, then Mars, then Jupiter, then Saturn. Oh, I added an extra line here. No, I didn't. I just mixed up my lines. Sorry, stand by. Earth, Mars, Jupiter, and Saturn. Now, I drew all of these planets lined up. That does not happen very often, or, you know, very, very, very infrequently. So all these planets are lined up. This is just what would happen, say, if Earth and Jupiter were lined up, Earth and Saturn, or whatever. So what happens is this sun's light, as it moves from the sun, typically what happens is if they're all staggered, the Earth will get some sun and Mars will get some sun, and the sun will kind of block it out. But if, say, that Earth is blocking or in front of Mars, what's going to happen is Earth is going to absorb that sunlight, blocking out Mars, and then you're going to be able to see Mars better because the light might pass around Earth and kind of get directed around Mars, but it's not going to wash out Mars. Same with Jupiter, same with Saturn. And those are the ones you can see without a telescope. And you can see those planets on early evening and in the morning. So for number 25 in the bold, it says sometimes Earth passes between Mars, Jupiter, and Saturn and the sun. This blocks out light and allows people to see them. So that's that illustration right here. You can see Venus and Mercury only in the evening or in the morning. And what is the brightest object in the night sky other than the moon? That would be Venus. You can actually see most of these planets in the summertime. That's a good time to see them in the fall, early spring. Those are our best times to view them, particularly on the beach if you can get to a beach, because that blocks out a lot of the light, or if you're in some rural areas. Mars is a very reddish color. Venus is very, very bright. And then you can download any type of star app, constellation app on your phone. You can just hold it up and it'll show you. Some of you might have done that before. So I encourage you to get out there and take a look as we move into these warmer months, and get out there each night and see if you can find one of them. So thanks for stopping by. Like and subscribe. I'll see you later.